Hello, welcome to next lecture on real analysis. So, in this we will discuss one theorem related to Riemann-Stieltjes integral. I think you may see the last lecture one. In this, in that we discuss about Riemann-Stieltjes integral. So here we will discuss the theorem related to Riemann-Stieltjes integral. Let's look the theorem. If P star is a refinement of P, then L of Pf alpha, that is lower sum of the function f over closed interval AB, less than or equal to lower sum of f over closed interval AB. But in this case, P star, here P. So, if P star is a refinement of P, I think the refinement is a new term for you. So, let's look what is a refinement of P. P star is a refinement of P if and only if P star covers P. P star covers P, or P star or P is contained in P star. Okay, so that is suppose let A, B be a closed interval and P be a partition of this closed interval and dividing into finite set of points, and this is P, partition P. And let's look the partition P star. So it contains an extra element, maybe one or more than one. Here I am taking a single element, X star. So when we look to this P star contains P. Okay, so P star is said to be a refinement of P. That's all about this idea. So let's look the proof of this statement. So we have this. So from this we can take this, and that means we can take this LHS to right side, then it becomes like this minus this greater than or equal to 0. The equation this becomes this when we take this to RHS. Okay. Then we need to prove this is greater than or equal to 0. That means this is positive. We want to prove that. So we already know lower sum. Lower sum is denoted by this. Lower sum is denoted by this. We know that this equal to this. Okay. This is the difference between the interval. Okay. Here we can see alpha. We use alpha because it is Riemann-Stieltjes integral. That means in Riemann integral we use x. In case of Riemann-Stieltjes integral, instead of x we will use alpha of x. Okay. So if you have any doubt, please visit the lecture 1. In that we discuss all the notations. Okay. So, and we also know that infimum of f of x is denoted by small m. So in this case I am taking here P star is a refinement of P and x star is the new element. So it will be like this. X star can be taken here or here, anywhere we can take. I am taking here. So I am considering an interval x I minus 1 and x star. So the infimum value of this interval is denoted by W1. Similarly, the interval, this interval's infimum is denoted by W2, and this interval's infimum is denoted by M1. That is xi minus 1 x star. Consider this interval. This interval have an infimum and have a suprimum for the function f of x. So I am denoting the infimum f of x as w1. Similarly, when I am considering the interval x star and xi, I am taking w2 as infimum of f of x. Similarly, when I am considering si minus 1 and xi, I am considering this interval also has a infimum f of x. So I am taking that as m1. So these are the substitutions. Then I am substituting these values to this. So we already know this. Here we are taking a single interval. So this is not necessary. That is sigma I equal 1 to n is not necessary. Instead of m, that is infimum f of x, we are taking w1 for the interval xi minus 1 less than or equal to x less than or equal to x star. So here instead of this, what will come? Let's say what will come. That means w1 into delta alpha of xi. That means the difference between the interval. If I am taking xi minus 1 x star, then the difference will be x star minus xi minus 1. Here we are discussing Riemann's Stieltjes integral. So instead of x, we are taking alpha of x. So it comes like this. Instead of L of P f alpha, instead of L of P star f alpha, we are substituting this value, that is these two things. Then instead of this, we are substituting the value this. So we will obtain like this. Then we need to solve this equation. So before solving this equation, for more easy, we will add alpha, we will minus alpha of x star and plus alpha of x star to this term. Then it will come like this. Okay. Then from this step, we can write like this. Okay. Then we already know that w1 is greater than or equal to m1. Similarly, w2 is greater than or equal to m1. So we can say that this term is greater than or equal to 0. That means this term is positive and this also will be positive, greater than or equal to 0. Then if we add these two terms, this must be greater than or equal to 0. That's all about the proof. So if P star is a refinement of P, then we want to prove this. So similarly, we can prove part 2. So please do it by yourself, part 2. And if you have any doubt, you can ask me through comment section. It is similar. Instead of infimum f of x, use suprimum f of x. That is the only change for this. And similarly prove like this. Okay. I think you all got an idea about this theorem. If you have any doubt, please please say through comments, or please see the before lecture. That makes you more clear. Okay. Thank you.